Okay, so number 51, you have to find an equation of all tangent lines to the graph that have a slope of -2. So the first thing we're going to do is find a general expression for the derivative, and then we're going to look at specific places where the derivative is actually -2 because that's what it means for slope to be -2. So our f of x is cosine inverse of x. And this is just a formula, so you have to memorize that it's 1 over square root of 1 minus x squared. But it's negative because it's cosine. Okay. So you are looking for places where this is specifically -2. Okay? So if you are looking for 1 over 1 minus x squared to be equal to -2, then you want 1 minus x squared to be positive 1/2. Okay, because 1 over 1/2 will give you 2, and they're both negative. Okay, so what we're going to do is we're going to square both sides, and we get 1 minus x squared is equal to 1 over 4, which will result in x squared is being equal to 3/4. Now, a couple of things to remember. When we take square roots of both sides, we do have to do plus and minus. So this will give us x being equal to plus or minus square root of 3 over 2. Okay. So those are the two places where it could be, the slope can be -2. Now the only thing we need is we do need to find the y value for the given x. So we need to figure out what is the y value when x is square root of 3 of 2. So we're looking for cosine inverse over 3 over 2. Now this is just a unit circle. So basically, I'm going to use a blue pen here. What you're looking for is, and remember cosine inverse can only be in the first or second quadrant. So you want the cosine, so the x, this is really bad. You want the x coordinate of the unit circle, of the point in the unit circle, to be square root of 3 over 2. And that happens when the angle is pi over 6. So this will be equal to pi over 6. And then the second place is going to be when x is negative square root of 3 over 2, which is cosine inverse of -3 over 2. So again, you have to remember the unit circle and also the restrictions for the inverse cosine. So it's we can only be in first or second quadrant, and cosine has to be negative. So then you're going to be here. And our reference angle is still pi over 6. So if you're here, then your actual angle that you get is going to be 5 pi over 6. So this will be 5 pi over 6. So you have the x value, the y value, and then the slope is -2. So your two equations are going to be y minus pi over 6 is equal to -2 times x minus square root of 3 over 2, and y minus 5 pi over 6 is equal to -2 times x plus square root of 3 over 2. Okay, so then just to check your answer, what I'm going to do is I'm going to graph it on a graphing calculator, and we're going to graph the original function and the two tangent line. And we want to make sure that they look like tangent, and then they actually have a slope of -2. So what I did is I entered my original function, so cosine inverse of x. Then I entered the two equations we got, and I used point slope form except for I added the y value to the right side, so we get y by itself. So these are the two equations that we got. So take a look at what happens when we graph. So the blue one is the cosine inverse, and red and black are going to be the tangent lines, and then they look tangent at this point and at this point. They both look they both have a slope of -2. So if you go from here, you go down 2 units over 1 unit. So you can clearly see that the slope is -2. So there's two equations, and they are they are the two equations that we found. So the final answer is going to be these two equations right here. And when I wrote the answer on the board, I used slope-intercept form, which is not necessary. You could definitely just use point-slope form.